Walk into a typical American home, lift the toilet lid, and one thing can look strange if you're used to bathrooms elsewhere. There is a lot of water sitting in the bowl. Why? The answer is hidden inside the porcelain, in a siphon. And following that siphon leads to a much bigger story. How plumbing locked in a design, and what happened when America suddenly demanded that it flush with much less water. Because this isn't really a story about Americans preferring more water in a toilet bowl. It's about infrastructure. Once millions of bathrooms are built around a particular fixture, its shape, its drain connection, its plumbing, improving that fixture becomes a constraint problem. And in the 1990s, that constraint became very real. First, the water. Every conventional toilet needs a water seal between the bathroom and the sewer. That standing water helps prevent sewer gases from coming back through the drain. But the common North American residential siphonic design uses that water as part of a particular flushing system. Behind the bowl is a curved passage called the trapway. It rises, bends, and drops toward the drain. That shape is the key to what happens when you flush. Press the handle and water rushes from the tank into the bowl. On many siphonic designs, a jet helps direct water toward the trapway. As the passage fills, a siphon develops. The moving column of water helps pull the contents over the bend and into the drain. Then air enters, the siphon breaks, and you hear that familiar final gulp. That sound is the mechanism revealing itself. Now compare that with a washdown toilet. Instead of depending on the same siphonic action, water pushes the bowl's contents through a relatively wide trapway, and the visible difference is striking. Toilet performance researchers describe typical North American siphonic water surfaces around 60 to 80 square inches. The European-style washdown fixtures in their comparison were around 20. That big American-looking pool isn't simply extra water waiting to be wasted. It is part of a different bowl and trapway geometry. Each approach brings trade-offs. A larger water surface helps keep waste from sitting directly on dry porcelain. But creating a reliable siphon requires a relatively restricted trapway. A washdown design can use a wider passage, which can reduce clogging risk while typically leaving more exposed bowl surface. So the visible water level is really the first clue. To understand why the North American design persisted, you have to look below the floor. By the middle of the 20th century, siphonic fixtures were already formalized in American standards. A US commercial standard published in 1949 described siphon jet water closet bowls with an integral flushing rim, a jet, a siphon trapway, and specified water surface and seal dimensions. That document matters because it shows this basic architecture was established decades before modern, federal water efficiency rules. The next clue is even more physical, where the drain is located. Plumbers call the measurement the rough-in. The distance from the finished wall to the center of the toilet's floor drain connection. For North American toilets, 12 inches became the most common dimension, although 10 and 14-inch installations also exist. In the washdown arrangement examined by toilet performance researchers, that measurement was about 5 inches. So switching between these fixture systems is not necessarily like replacing one appliance with another. The toilet has to meet a drain that may already be embedded in the building. That physical compatibility became especially important after 1992. The Energy Policy Act established national water use standards for toilets. Beginning in 1994, the maximum for most residential-style water closets became 1.6 gallons per flush. Some states and cities had already adopted efficiency requirements. Now manufacturers faced a national limit. The amount of water could change. The bathrooms already built across the country could not simply change with it. That created the central engineering problem. European-style washdown toilets demonstrated another way to flush with relatively little water. But the systems differed in bowl geometry and installation dimensions. Researchers examining the American transition concluded that manufacturers could not simply drop those European fixtures into existing American bathrooms. Instead, they largely had to make the established siphonic architecture perform on 1.6 gallons. And some of the early results exposed how difficult that could be. Early 1.6 gallon toilets developed a bad reputation. Some models performed well, others didn't. Researchers documented complaints about weak flushing, clogging, and repeated flushing. They also noted that some early models appeared to be adaptations of older, higher volume designs rather than toilets optimized from the beginning for the new limit. The important distinction is that 1.6 gallons itself was not necessarily the problem. The design had to catch up with the new constraint, and eventually it did. Which leads to one of the more unexpected parts of modern toilet engineering. Manufacturers have to demonstrate that efficient toilets can actually remove waste. EPA's WaterSense program requires qualifying tank-type toilets under its current specification to use 1.28 gallons per flush or less and meet performance requirements. One of those requirements is a solid waste removal threshold of at least 350 grams. That creates a useful reversal. Look into a modern siphonic toilet and the bowl may still appear unusually full to someone familiar with washdown designs. But the amount of water sitting in the bowl is not the same thing as the amount used per flush. The standing level comes from the bowl and trapway geometry. EPA says WaterSense labeled residential toilets use 1.28 gallons per flush or less, at least 20% below the federal 1.6 gallon standard. So appearance alone tells you very little about efficiency. There are even siphonic models sold in the United States rated at 1.1 gallons per flush. The familiar bowl shape survived, but the engineering inside it changed. That is the larger pattern here. Instead of rebuilding bathrooms around an entirely different fixture system, manufacturers improved performance inside the constraints of the plumbing already in place. There is an important complication though. There is no single American toilet. The siphonic tank toilet is a common North American residential design, but public and commercial buildings can look very different. In an airport, stadium, school or office, you may find a flush-ometer valve toilet. No familiar residential tank, just a valve connected directly to the water supply. EPA estimates that nearly 27 million flush-ometer valve toilets are installed in the United States. Homes also include pressure-assisted toilets, dual flush models, high-efficiency siphonic designs, and other variations. And there is another limit to the idea that using less water is always better. A toilet has to clear the bowl. Then that waste still has to travel through the building's drainage system. When EPA developed requirements for high-efficiency commercial flushometer toilets, stakeholders raised concerns about waste transport through long drain lines at very low flush volumes. EPA responded by setting a minimum flush volume of 1 gallon for WaterSense labeled flush-ometer valve toilets. That is a useful boundary on the entire story. Efficiency cannot be judged at the bowl alone. The fixture, the drain line and the plumbing system have to work together. Which brings us back to that strangely high-looking pool of water. Why do many North American residential toilets look so different from washdown toilets used elsewhere? Because the visible water is the surface expression of a siphonic system hidden inside the porcelain. That system became established in American standards and buildings. Drain locations and fixture dimensions reinforced it. Then federal efficiency rules required manufacturers to make that existing architecture work with much less water. The rough first generation of low-flow toilets was not the end of the design. It was the pressure that helped force the design to improve. So, a visitor may look into a North American toilet and simply see too much water. But hidden behind that water is a siphon. Beneath the siphon is a drain connection fixed into a building. And behind that connection is a history of standards, water limits, and redesign. It is a surprisingly large system hiding inside an ordinary piece of porcelain. And that is why changing the toilet was never just about changing the toilet.